My name is Micah Siegel. Today, my dad and I want to tell you how atoms and molecules are constructed. Ready, Dad?
Ready, Micah.
Okay. This is the periodic table of the elements.
Sorry, that's my turn. It shows all the elements we know today. In this video, we're going to describe the first 18 elements. Elements are made of fundamental particles. The fundamental particles are neutrons and protons, which make up the nucleus, and electrons, which orbit around the nucleus. But this picture isn't to scale.
If the nucleus is the size of a grape, then the electron's orbit is the size of a football stadium.
Wow. In this presentation,
red dots always represent electrons.
Electrons are small.
Very. Here's the shape of the orbits around the nucleus that the electrons travel in.
These are called shells. They are made of orbitals.
We're going to tell you a few lies to keep things simple.
We are?
Yeah.
This is hydrogen, the simplest atom.
And the most common element in the universe.
Hydrogen is what stars are made of.
The nucleus has one neutron and one proton.
This first orbital is in the shape of a sphere. It's called S1.
The red dot represents the electron.
When we show an orbital like this, it isn't exactly where the electron is.
It's an area that represents a 90% chance that the electron is found there.
It could be far outside the sphere, but most of the time it's at home inside the sphere. We have to make it small because we're going to be building on top of this orbital.
In 1766, Henry Cavendish figured out that hydrogen was an element.
And in 1783, Antoine Lavoisier named it hydrogen, which means giving off water.
When you burn hydrogen, it attracts oxygen molecules and gives off H2O, or steam.
This is helium, the second most abundant element in the universe.
It has 2 electrons,
which fill up the outermost orbital, because this orbital can only hold 2 electrons.
Helium is a noble gas.
It doesn't combine with the other elements.
But it's great for making balloons float, and it gives you a squeaky voice.
I've heard that.
Helium was discovered
by
a
number of
astronomers and chemists
around 1900.
Lithium has 1 electron in the second orbital.
This orbital is called S2.
It goes around the smaller S1 orbital, which is still holding 2 electrons.
So there are
3
electrons in
lithium.
That's right. Lithium is a very soft white metal found in deposits or in lakes. Lithium was discovered in 1817
by Johann August Arfwedson.
I like how you say Arfwedson. Here's beryllium. It has 2 electrons in its second orbital, called S2.
Now that orbital is full.
You know, I think all orbitals have 2 electrons at most. Beryllium is super light and strong.
It's used for very exotic products.
In fact, the mirror of the James Webb Telescope is made of beryllium, which is stable at very low temperatures.
It's also toxic. Exposure to the dust can make you very, very sick.
Oh my. Beryllium is an alkaline earth metal. You can see all of them in the second column from the left. See that? All those metals are very soft.
Did you know you probably have about 30 micrograms of beryllium in your beryllium in your body right now?
I do?
Yes, but don't worry, that's not enough to be harmful.
This is boron. It has 2 electrons inside S1 that you can't see, and 2 here in S2. Both of these orbitals are spherical.
It also has 1 electron in a funny-shaped orbital that looks like a couple of balloons. That orbital is called P1.
Boron is very light and strong.
It's used in skis, tennis rackets, bikes, and other high-end products.
Boron was discovered in 1808. Boron is the lightest metalloid.
The metalloids are the light brown group going diagonally.
Weird, but okay.
Boric acid is used to kill bugs.
Maybe it bores them to death.
Yep.
Sure.
This is carbon. It has 2 electrons in S1 that you can't see and 4 in S2.
In carbon, the first p orbital is full. It has 2 electrons.
Carbon has 6 electrons total. Carbon is very important for life.
Our bodies are made of carbon.
We need carbon for energy and food and building homes.
Every living thing on Earth, from bacteria to whales and redwood trees, is made of carbon. Carbon was first recognized as an element by
Antoine Lavoisier, who also named hydrogen.
Well, but you could pronounce his name better than I can. Here's nitrogen. It has 7 electrons. The next p orbital, P2, is starting to fill up.
Nitrogen is an odorless gas.
An odorless gas?
Nitrogen is an odorless gas that makes up 78% of our atmosphere.
Most of what we breathe is nitrogen. Right.
Nitrogen was first isolated
by Daniel Rutherford in 1772. It looks like he may have discovered alcohol at around the same time.
Oxygen has 8 electrons. 2 in the inner S1 orbital.
2 in the S2 orbital.
And 2 p orbitals are full. Oxygen makes up 21% of the air.
And it's what our muscles use to burn their fuel.
Oxygen was discovered around 1774.
It likes to combine with other elements, as we will see.
This is fluorine, which has 9 electrons.
7 are visible.
Now we're starting to fill up the 3rd p orbital.
This is getting exciting.
The name fluorine comes from the Latin word flores, to flow. In 1886, Henry Moissan used a device like this to isolate fluorine for the first time.
I think I have one of those in the basement.
Neon has 10 electrons.
All 4 orbitals, the spherical S2 orbital and the 3 p orbitals, are now full.
That means the outer shell of neon is completely full.
The shell is everything shown here in blue.
Neon is a noble gas.
It was discovered in 1898 by 2 British chemists,
Sir William Ramsay and Morris Travers.
Did you know them?
No. Oh. When charged with electricity,
neon naturally glows red.
Wow.
Yeah. Now we've seen the whole second row from lithium to neon. As we start the 3rd row, we will add more electrons in a new, larger shell that goes around the shell we just saw.
Here's the first inner shell, remember?
Yep, it's still there, holding 2 electrons as usual. It's inside the second shell, which we just filled up.
Now imagine that the entire first and second shells are inside
this green ball, which represents S3, the 3rd spherical orbital.
This is sodium.
It has 1 electron in S3.
Sodium has 11 electrons total because there are 10 electrons in neon, remember?
Yeah, neon's inside there somewhere.
Mm-hmm.
The name sodium comes from the Latin sodanum for headache medicine because it was used, I guess, to help relieve headaches.
The symbol Na comes from the Latin natrium.
Natrium, okay.
Natrium.
Na. Sodium was discovered in 1807
by the English chemist Humphrey Davy.
A sharp-looking lad, isn't he?
Sure.
This is magnesium.
It has 12 electrons.
The first 10 electrons are all inside this green orbital.
Magnesium is a shiny, lightweight metal.
You actually need magnesium in all your cells. Did you take your magnesium today?
Yeah.
Oh, wow. Magnesium is an alkaline earth metal. Joseph Black discovered magnesium
in 1755.
Any relation to Jack Black?
No, probably not.
Probably not. Now we have arrived at aluminum. Aluminum has 1 electron in the p4 orbital, so it has 13 electrons in total.
It's a lightweight metal that loves to combine with oxygen.
Aluminum was discovered in 1825 by
Danish physicist Hans Christian Ørsted.
Add another electron and you get
silicon, another metalloid with 14 electrons. The p4 orbital is now full. I prefer my orbitals to be full, don't you?
Always with 2. Silicon is the second most abundant element in the Earth's crust. It's found in sand, glass, and computer chips. In 1824,
Jan Jacob Berzelius
separated pure silicon from oxygen. And he has a rather large neck, I would say.
Years before that, Scottish chemist Thomas Thomson gave silicon its name.
Phosphorus has 15 electrons, which brings us to a new p orbital, p5.
Phosphorus is a reactive nonmetal that glows in the presence of oxygen.
Cool.
It's in glow-in-the-dark toys and watches and other products. The name phosphorus comes from the Greek words for carrying light. Phosphorus was isolated in 1669 by Henning Brand.
Nope. Try again. When was phosphorus isolated?
In 1669 by Henning Brand.
And there's the man himself saying his incantations over the magic potion.
This is sulfur. It smells stinky.
How do you know?
Trust me, I know.
The p5 orbital is now full, so sulfur has 16 electrons. People have known about sulfur for thousands of years.
It's in our hair and nails.
Wow. You can find it in most places where there's hot water coming to the surface, like in Yellowstone. Have you ever been to Yellowstone?
Maybe. The reason our farts are so stinky is hydrogen sulfide.
Oh, we have a chemist in the family. Here is chlorine. It has 17 electrons, starting to fill up P6, the last orbital of this shell. God, the excitement is just crazy in here.
It's a yellow-green gas that kills germs and makes your swimming pool blue.
Chlorine means light green in ancient Greek. You speak ancient Greek?
No, of course not.
We're at Argon, one of the noble gases that doesn't mix with anything.
Now these 4 orbitals are full.
All 4 of these orbitals together make up the third shell. These are the first 18 elements.
Now we want to show how they bond with each other to make molecules that we see and use every day.
Okay, bathroom break, and then we'll come back and get the rest later. Good job. We're back, and we're changing the subject. Now we're going to talk about molecules. To do that, we're going to change how we show the shells.
Instead of showing all the orbitals as before, I'm just going to use circles to show each shell.
In this kind of diagram, we can see all 18 electrons of argon in shells 1, 2, and 3. See that?
Yeah.
Each of these circles corresponds to one of the shells we saw before.
Right. Also, the real name of these shells are K, L, and M, but we're not going to use those. Here, we're going to keep it simple and just use colored circles.
Well, then why did you tell everybody they're really called K, L, and M?
Because I thought they should know. All the other videos explain it.
Well, why do they start with K?
Nobody knows. It's one of those mysteries, like dark matter.
Now let's see how atoms bond to each other.
Let's start with ionic bonds.
Good idea. This is our symbol for a hydrogen atom.
It has 1 neutron,
1 proton,
and 1 electron. The red dot is the electron.
If you line them up side by side, you could fit 500 million hydrogen atoms in 1 centimeter. Wow. And here's a fluorine atom.
Notice that the fluorine atom has 1 electron missing from its outer shell.
And the hydrogen atom has one extra electron.
So when they come near each other, don't get in the way because they attract like magnets.
Let's watch. Ooh. This is called an ionic bond.
One atom has a complete outer shell, and the other atom gives its electron to complete the other one.
Hydrogen and the alkali metals have one extra electron in their outer shell.
So when they get near an element that is missing an electron, they naturally form an ionic bond.
Here's another one.
Sodium has one extra electron in its outer shell, and chlorine is missing one electron. They combine to make sodium chloride.
Who knows what sodium chloride is?
I do. Table salt.
Yeah, right. Now, magnesium and oxygen.
Magnesium has 2 extra electrons, and oxygen needs 2 electrons.
I can see that. They combine to make
magnesium oxide.
Very good, Micah. Do you know what magnesium oxide is used for?
Of course, Dad. Magnesium oxide is used to make the heating elements for stoves.
Wow, I didn't know that. All of the atoms in the second column, the alkaline earth metals,
naturally bond with all of the atoms in the third column from the right.
Yeah. Another kind of bond is covalent.
Right. That's where atoms share their outer electrons, so they all have complete outer shells.
Here we see 1 carbon atom and 2 oxygen atoms. They combine to make
carbon dioxide. Each atom has a full shell of 8 outer electrons.
You're making carbon dioxide right now just by exhaling.
Is it dangerous?
No, not at all.
Here are 2 hydrogen atoms and 1 oxygen atom.
Guess what they make?
I don't know, spaghetti?
Close. They combine to form water, which you need to make spaghetti.
Water has a covalent bond where each atom has a full outer shell.
Here are 4 hydrogen atoms and 1 carbon atom.
That's a lot of hydrogen atoms.
Let's see what happens. They combine to make methane,
which is also called swamp gas or natural gas.
Explosive.
Finally, we have 5 carbon atoms. They could all use 4 other electrons in their outer shell.
That's right, they could. It isn't easy, though, but with a lot of pressure, they bond covalently to form diamond, one of the hardest substances on Earth. Yeah, I think we're getting the hang of this.
Diamonds are clear because right when you say it, we're starting to get the hang of this. Diamonds are clear because the atoms are arranged in a grid.
Yeah. Remember we said we were lying to keep things simple?
Now I want to show you what the orbitals really look like.
Okay, go ahead.
The s orbital are spherical.
This is how we showed the p orbitals.
But in reality, the p orbitals are different.
What? You've been lying to me the whole time?
Yes, I have, Dad. If you take this shape of the p orbital and spin it into a kind of torus, that's the real shape.
Wow, I bet a lot of people don't know this. This is big news.
This is a real p orbital. It can hold 1 or 2 electrons. And remember, this is where the electrons can be found about 90% of the time. The whole third shell looks like this.
Ooh, complicated. That's what a shell looks like?
Yes, this shell can hold 8 electrons.
No wonder you didn't show this at the beginning.
Yeah, and ionically, we've reached the end of the video. Thanks to my brother Shai for making these 3D images.
Today we learned about the top 3 rows of the periodic table, the first 18 elements.
Hey, Dad, what about all the other elements?
Well, Micah, if enough people like this video and they share it and subscribe and copy the URL and send it to all their friends, I guess we'll have to come up with a fun way to teach them about more elements.
You'll find more resources in the description.
Thanks for watching.